Myself, Dr. Aravindan, Professor, Department of EEE, K.S. Rangasamy College of Technology. Today I am going to discuss about the construction, principal operation and the torque equation of DC motor. DC motor is a direct current motor, converts the electrical energy into mechanical energy. The direct current motor is a fairly simple and electric motor that uses electricity and magnetic field to produce a torque which turns the rotor and hence give the mechanical work. The DC machines are two types, namely DC generators and DC motors. DC generators convert the mechanical energy into electrical energy, whereas a DC motor converts the electrical energy into mechanical energy. In order to understand the operating principle of a DC motor, it is necessary to understand how does the current carrying conductor plays in the magnetic field and the current, how the conductor will experience the force. That we can able to understood from the Fleming left hand rule. In the Fleming left hand rule, we had to understood that in the stretch out our fingers right angle to each other from thumb and middle thumb, index finger and middle finger right angle to each other. So index finger will indicate the direction of the magnetic field and the middle finger direction of the current, and your thumb will indicate the direction of the magnetic forces. The force on the current carrying conductor, if the straight conductor is placed in the magnetic field, it produces a permanent magnet. The current flowing through a conductor in anti-clockwise direction. Due to the presence of two magnetic fields simultaneously, an interaction between them will take place in the force on the conductor. The force on the current carrying conductor is clearly explained from this diagram. So, from the excitation of the field supply, there will be a strong magnetic field from N to S will be there. Then inside that magnetic field we place the current carrying conductor. So as per the Fleming left hand rule, there will be a current in the current carrying conductor. So the direction of the conductor, it will be going to direction clockwise and anti-clockwise direction. It will be going to declared by the Fleming cork screw rule. So the conductor will have a clockwise direction in this figure number 2, a clockwise direction. Then from top to bottom there will be a fluctuations through the magnetic field. So interaction between these two fluctuations, we have a left hand side we have a maximum amount of fluctuations because of the same direction. The right hand side, right hand side we have a more number of fluctuations, and then left hand side we have a less number of fluctuations because of it will have a counter direction. So minimum amount it will be going to cancel from the left hand side. So the accumulation of the fluctuations in the right hand side, the conductor will have a force on the from the left to right. So the magnitude of the force that we are going to declare by the magnitude of the force experienced by the current carrying conductor placed in this magnetic field is given by the formula. Clearly the formula F is equal to BIL newtons. B will be the flux density produced by the magnet, I will be the current flowing through the conductor, and L will be the length of the conductor. So the direction of the rotation of the motor depends on the direction of force extracted on the armature winding, and the direction of the force experienced by the current carrying conductor is given by the Fleming left hand rule. So mainly the windings of DC machines have a two winding. One is a field winding, another is armature winding. The field winding is a stationary which does not move at all, and armature winding is mounted on the shaft. So it can rotate freely. So connection of the windings for the operation as a motor, to operate the DC machines as a motor, the field winding and armature winding is connected across the DC supply. The DC motor, the principal operation of a DC motor, when the current carrying conductor placed in a magnetic field, it will experience the force. In case of DC motor, the magnetic field is developed by the field current, and the current flowing in the field winding and the armature winding plays the role of the current carrying conductor. So armature winding experience the force and start rotating. So the diagram clearly shows that we have a permanent magnet in that left and right hand side N and S. Inside that we have current carrying conductor. That current carrying the conductor will going to give the supply from the DC sources through the carbon brush and then commutator. Through the commutator there will be a supply will be going through the conductor. So the conductor will in turn it will be called as the current carrying conductor. So already we have magnet in that both the side of the conductor N and S. So interaction between that magnetic fluxes and the current carrying conductor, the force will be extracted on the conductor as per the Fleming left hand rule. So this is a construction of DC motor. We have yoke and then pole shoes and then armature winding and then armature slot, brush and the commutator and then various field winding and then armature winding. It will be the various parts of the construction of a DC machine. So important parts of DC machines: yoke, field winding, brushes, gears, then poles, armature winding and then commutator and the brushes. Let us discuss about one by one how our construction of the DC machines various parts will be going to present in the DC machine. So first one is yoke. It is the outermost cover of the DC motor and also called as the frame. It produces protection to the rotating and then other part of the machine from the moisture, dust, etc. Yoke is an iron body which provides the path for the flux to complete the magnetic circuit. It provides the mechanical support for the poles. Material used for the construction of the yoke is low reluctance material such as the cast iron and then silicon steel, rolled steel and then cast steel, etc. Second portion of this machine, DC machine is the pole. So pole is a very important part in the DC machine. Particularly, it's develop the field fluxes in the DC field flux in the DC motor. Poles and pole courses poles are electromagnet actually. The field winding is wound over it. It produces the magnetic flux when the field winding is excited. The construction of the pole is done using the lamination of particular shape to reduce the power losses due to the eddy current. Pole shoes, it is an extended part of the pole. Due to its physical typical shape, it enlarges the area of the pole so that the more flux can pass through the air gap to the armature winding. Material used to construct the pole shoes are low reluctance magnetic material such as the cast iron steel or cast iron. It is used for the construction of the poles and the pole shoes. Field winding, of course, this is a very important winding in the machine to develop the main magnetic fluxes over your armature winding. So it's have a field coil wound on the pole. The coil wound on the pole core are called the field coil. The field coils are connected in series to form the field winding. The current is passed through the field winding in a specific direction to magnetize the poles and pole shoes. Thus, the magnetic flux is produced in the air gap between the pole shoes and armature. Field winding is also called as the exciting winding. The material used for the copper conductor is conductor is the copper. Due to the current flowing through the field winding, alternate N and S pole are produced in the field winding. Armature. This armature core is a cylindrical drum mounted on the shaft. It is provided with a large number of slots all over its periphery and it is parallel to the shaft axis. Armature conductor are placed in these slots. Armature core provides a low reluctance path to the flux produced by the field winding. Material used to construct the armature core is high permittivity, low reluctance cast steel or cast iron materials is used to construct the armature core. The laminated constructions. The laminated construction of the iron core is used to minimize the eddy current losses. The very important one is how we are going to reduce the eddy current losses. To reduce the eddy current losses, we should go for the laminated construction of the iron core. Armature winding. The armature conductor is placed in the armature slot present. Commutator, the fifth part of that construction, DC motor is commutator is very important one. It is cylindrical drum mounted on the shaft along with the armature core. It is made up of a large number of wedge-shaped segments or hard drawn copper. Its segments are insulated from each other by thin layer of mica. Armature windings are tapped at various points and these tappings are successively connected to the various segments of the commutator segments. Then function of the commutator is to convert the AC EMF, induced EMF into DC EMF in the it helps to produce the unidirectional torque. Materials used to construct our computers, it is made up of copper and then insulating materials between the segment is the mica. Brushes, commutator is rotating, so it is not possible to connect the load directly to it. So hence the current is conducted from the armature to the external load by the carbon brushes, which are surface of the commutator. So here it is clearly the diagram shows that the carbon brush, it will be placed over the commutator segment. So depends upon that number of ports, there will be a number of carbon brushes. It may be 2 or it may be number of multiple of the 2. So even number of carbon brushes will be placed over the commutator segment. So back EMF. So once the machine is running as the motor, there will be a generator in action of the motor. So because of that, we have to explain about the back EMF of the motor. Then back EMF will be developed inside our armature conductor while this machine is run as the motor. So when the armature winding of a DC motors start rotating in the magnetic flux produced by the field winding, it cuts the lines of magnetic flux sciences. So hence according to the Faraday's law of automatic induction, there will be a induced EMF in the armature winding. As per the Lenz's law, this induced EMF acts in the opposite direction to the armature supply voltage. Hence this EMF is called as the back EMF, and then is denoted by back EMF E suffix B, that is equal to then number of poles and then the speed in RPM, the flux lines is produced by the main field, and then number of conductors in the armature winding with the ratio of 60 into that A will be the number of parallel paths in the armature winding. So the unit is volt. Again, that back EMF is according to symbolic representation the back EMF is plus and minus will be given from the outside source. Then EB will be developed inside your inside our winding. Then EB will be flow from inside armature winding to the towards the supply nature, so that the direction of the EB will be from inside the winding to outside the towards the supply nature. So in the armature conductor cuts the magnetic field, EMF induces in the conductor, as this is called our back EMF. So the diagram clearly shows that how the flux lines, supply will be given to the field armature winding. Then once it is given the armature winding, it will convert it will be going to act as a current carrying conductor. Once it will act as a current carrying conductor, there will be a magnetic field in the, there will be force on the current carrying conductor. Once it start to rotate, there will be a back counter EMF as per the generative action of the motor. There will be a current will be developed inside our machine that will be going to flow opposite to our supply nature. So it will be going to have a back EMF. This green line, it will clearly says says that how the counter EMF will be going to oppose the supply nature. Again, this is the direction of the back EMF opposes to the supply voltages. This will be equivalent circuit of the DC motor. Then relation between the back EMF and the supply voltage is given in the clear this equation. Back EMF is equal to the supply voltage Vt minus that voltage drop in the armature winding, that is Ia into Ra. So advantages of the back EMF in the DC motor, it's mainly it's have a it is a tremendous job it will going to do in the operation of the DC motor. So once the electrical load will be added on the machine, there will be a difference in the current, in the load current. So difference in the load current, there will be a reduction in the speed of the DC machine. So once the DC machine speed is reduced, then according to that, there will be back EMF will be reduced. So because of the back EMF reduction, the voltage drop due to the voltage difference due to the drop in back EMF, the voltage drop will be voltage present in the armature winding will be increased. Because of the increment in the voltage difference in the armature winding, there will be a increment, more force will be acted on the armature conductor. So the torque will be increased according to that, the level of voltage it will be going to increase. So vice versa. So the torque will be increased, then now the voltage speed will be restored to original positions, whatever it may be run before the load will be added on the machine. So likewise, it will be very important role in the back EMF will act as a speed regulating mechanism in the DC motor. So we have three type of conditions. First conditions, motor is running at no load. In that position, the less amount of torque only required then small current also it is required to produce the less amount of current, then this back EMF will be more back EMF. So the reduction between that back EMF and then supply voltage will be very less, so that small current and then small torque will be enough to run the machine. The only no node losses and then friction and windage losses only you have to supply from the motor. So the current taken by the machine is, it will be very less. Then the second one, suddenly load is increased in the machine, then there will be instantly your speed will be drop. The because of speed will be down, then back EMF will be decreases. Once the back EMF decreases, there will be a difference between back EMF and then the supply voltage will be increases, depends upon that the torque will be increases, so the speed will be restored. Whereas load is suddenly decreases, this is very important interesting conditions. If the load is suddenly increases, that speed increases. Once the speed is increases, back EMF also increases. Once the back EMF increases, the difference between voltage, supply voltage and the back EMF will be reduced according to that. So there will be a reduction in the armature current. Once the armature current is reduced, then the torque and the armature current will be directly proportional. So because of that, torque also reduced. Now the motor shaft will be retarded to the less in the speed. So the incremental speed will be again restored to the original positions. This will be the major the significance of our back EMF. So this is the type of the motor circuit model. So depends upon that circuit model, we have majorly we have two type of the motor. One is separately excited and then another type is self excited. Separately excited, the field winding will be separately excited by the external DC sources. Self excited, the field winding will be supplied by its own EMF developed by developed by the motor. So that suppose how we are connected our field winding to the armature winding depends upon the connection. We have three type of the DC motor. One is a series winding, series motor. The series motor, the winding and then armature winding will be connected in series. So it will be going to call a series motor. Then if the shunt field winding will be parallelly connected with the armature winding, this type of the motor will be called as the shunt motor. Then we have a combination of series and shunt. We have a long in a single machine we have simultaneously series winding as well as shunt winding will be connected. Suppose that shunt field winding will be in series with both armature winding and the series field winding. That type of machine is called a long shunt. Then suppose the armature winding and the field winding is connected parallel, the series winding is separately connected in series with both these two winding, then that will be going to call as the short shunt motor. The voltage equation of the DC motor, voltage equation and then the equivalent circuit of the DC motor clearly shows that its E will be the back EMF, then IA will be the current drawn by the machine, then VB will be the supply voltage and then RA will be the internal resistance of the machine. The voltage and power equation of the DC motor, V will be the supply voltage, that is equal to back EMF plus the voltage drop due to the armature winding. So VIA will be the voltage drop due to the internal power taken by the machine. VIA, that is equal to back EMF, total amount of power developed as a mechanical power developed EBIA plus the drop in the power is IA squared RA. So VIA electrical power supplied to the motor, then EBIA electrical equivalent of mechanical power produced by the motor, IA squared RA the power losses taking places in the armature winding. Thus we can have a balance equation that EBIA will be the gross mechanical power developed, that is equal to input minus losses. The input will be the VIA minus IA squared RA. So input minus power losses. So that will be going to again called as the gross mechanical power P suffix M. So torque equation of the DC motor. Before discussion about the torque equation of the DC motor, it will be recall that the concept of the torque for reference. The torque means that is the running moment, turning moment or a twisting moment for the force on an axis. The measure a torque as the product of the force and then radius which in the force acting in the same directions. So here n will be the speed in RPM and omega will be the 2 pi n by 60 radians per second, and then clearly shows that your clockwise direction, suppose the rotation will be there in the the pulley, then from right to left there will be a force will be acted. So torque equation, the mechanical power required to rotate the shaft on the mechanical side is torque into angular velocity omega, and then T will be the torque in Newton meter, and omega will be the angular velocity radians per second. Gross mechanical power produced by the motor on the electrical side is EB and IA, back EMF into armature current. Then equating these two equations will be, we can get EB IA is equal to T omega. So omega already we declared that 2 pi n by 60, that n is the speed in the RPM, and the back EMF is already we declared that formula, that n pi ZP by 60A. Then these equations become input back EMF n pi ZP by 60A substituted in place of the EB, then IA, that is equal to torque into omega 2 pi n by 60. So torque, we require torque is equal to P pi Z IA by 2 pi A, that is equal to all the constants will be declared, calculated as in the value, numerical value, that is 0.159 P pi Z IA divided by parallel path A, that is equal to 0.159 P Z by A into pi IA. So now this is the total torque equation of the DC machine. So torque is directly, already we declared that torque is directly proportional to flux sciences and armature current taken by the machine. So thank you friends for your patient listening, and then if any query, then you can ask me.